Myself, Dr. Naveen, the course Metallurgy and Material Science. Today's the topic is introduction for the course Metallurgy and Material Science. And these are the 5 outcomes of the course Material Science and Metallurgy. So at the end of the course, the students will be able to get all these 5 course outcomes, and the course outcomes maps with program outcomes, formerly known it as a POs. So this course map correlated with the POs PO1, PO7 and PO12, and also we are mapped the course outcomes with the consideration of Bloom's taxonomy. So in this, we mention it as a DOK. With this, we correlated map our course outcomes. And coming to the metallurgy and material science. So the basic definition of the material science is an interdisciplinary field concerned with the understanding and applications of the property of the matter, or it is a science which helps to identify the property of the material, so known as material science. And coming to the metallurgy, it is an extraction, it is an art. So it is helps to identify the metallurgical structure of the materials. So the basic materials are classified as metals and non-metals. And further, the metals are classified ferrous and non-ferrous, and non-metals are classified as plastics, composites, and ceramics. And further, the ferrous materials are classified as iron and steel. The non-ferrous materials are light metals, superalloys, and other form of the metals. So, coming to the non-metals, the properties are non-ductile, poor conductivity, non-malleable, non-lustrous, brittle. And these are the some of the differences between the metals and non-metals. For example, consider copper jugs, metal or iron screws, and medals. And for non-metals, diamonds, carbon, silicon, all are the examples for the non-metals. And moreover, whatever we are considering, the material or metals or non-metals having their own structure, with the formation we are classified into different of the structures as BCC, FCC and other form of the structures. So these are the one of the example. And considering the steel, moreover, we have the difference between the steel and iron. So it is the full of pack of ferrite atoms, then it is called iron. And the iron is combined with the formation of the carbon in the iron ferrite is called steel. So this is the microstructure of the steel. And various types of the other materials like cast iron. Whenever we are adding the carbon into the iron, then the material becomes, the properties of the material becomes changes. So depending upon the composition of the carbon, we are named as a different terms. For example, the carbon content is up to 2.11%, then we call the material as steel, and beyond that composition of the carbon, we call the material as cast iron. And depending upon the composition of the carbon, again the cast irons are classified as nodular cast iron, gray cast iron, white cast iron. So depending upon the grain size, particle shape of the material, we named as a different names. And the best example for the steel and cast irons are railway tracks. And so whenever the carbon content is added into the iron, the structure, the composition of the carbon varies the properties of the material. So we have to calculate how much quantity of the carbon can be soluble in the iron. So depending upon the atomic weights, we are considering what is the atomic weight of the carbon, and depending upon the weight of the ferrate iron, so we are considered molecular weights. Then the maximum solubility of the carbon in iron is 6.67%. And moreover, we have to learn the properties of the metals or materials. So whenever we know the properties of the material, so depending upon our requirement, we can replace the materials very easily, so that the cost of production may be decreased, the cost of time may be decreased. So we have to learn the properties of the materials. For example, consider pure iron. The melting point is 1538 degrees centigrade, and cast iron, moreover, from 1100 to 1300, and coming to the steel, which is around 1500 degrees centigrade. And the other properties are ductility, electrical conductivity, cost of the materials. So whenever we are gone through the completely the properties of the materials, then we can easily replace the materials with our requirement. And the major applications of iron, steel, and cast iron. So we are replacing depending upon the properties. So steel has the most applications in engineering. It has superior qualities to most other materials, especially when considering the cost. And some of the steel is used in almost every structural part, unless density is an issue. Most planes would be made of a lighter material than steel, but landing gear is still solid steel. Steel is used for buildings, cars, bridges, whatever the strength is required for our application. And the final thoughts and further reading of the course, we are considering the levels L1, recall, and understanding. And considering for the program outcomes, so PO1, and it also helps for lifelong learning, PO12. Do you know what alloys and how they differ from the materials? So this course mainly helps to know the properties of the material, utilization of the material. According to our requirement, we can replace any material with the similar or equivalent material with low cost and low efforts. And iron is one of the most important element of modern society, because of all the things can make with iron. However, pure iron is not that useful on its own. Some ingredients, composition may lead or change the properties of the material. For engineering applications, we need anisotropic type of the materials. Adding carbon to iron produce steel, the most widely used metal. Steel has an excellent combination of mechanical properties and is among the cheapest material. adding even more carbon to iron, produce cast iron. So it is the composition from 2.11 to 6.67%. So cast iron has some benefits compared to steel, mostly because it has a lower melting point for parts that need to cast. Cast iron is usually cheaper than steel. Cast iron has flecks of graphite, which also helps to dampen vibrations. With this introduction, we can move forward for this course. Thank you.